Hi friends, let's look at this problem, merge two sorted list. This is a follow-up for the video of problem 2570. It's still merge two sorted list, but here it has some data structure called linked list. So we want to return the two linked lists into one sorted list, and we want to return the head of merged linked list. So here we are going to practice this one. It's still same as two-pointer method. So here let's write the trick as two-pointer, right? But each pointer in this problem pointing to the current state of the two lists respectively. So here also I want to introduce another trick. So it's called dummy node or pseudo node. So this dummy node and pseudo node will be very important in very convenient in this type of problem. So here, let's see, if you have such thing 1, 2, 4 and 1, 3, 4, the result will be 1, 1, 2, 3, 4, 4, right? So here, let me first initialize this dummy variable, dummy node. It's a list node class. So see, we can initialize a value. So the value say negative 404, right? Then we can set the current to be dummy. And then I'm going to set its next to be whichever is small between this list 1 and list 2. So again, this is a while loop corresponding to the while loop in the video for problem 2570, right? So while list 1 and list 2. So if what we want to return actually is dummy next, because dummy is the one we introduced for us to do the problem coding conveniently. So this is what we want to return. So we just need to fill out this block. So here, first thing, if we look at the assumption, so the number of nodes in both lists can be 0, right? In other words, both lists can be null. So if both of the two lists are null, so we are not going to enter this while loop. Then because dummy we initialize as this, so the default next will be none. So we're going to return a none. That's actually right. So this is the one thing. Another thing we need to notice is that the two list can be, this actually just we explained the example 2, right? So here, example 3 tells us it's possible that the two lists have different lengths. So the example 1 actually is very special because these two lists given are of the same length. So with that said, if you notice the different situations, coding it should be rather straightforward. So now let's do a check. If list 1 value is less than list 2 value. So if they are equal, actually we can also absorb it. So we can write less than or equal to. So in this case, we can first add the current next to be the list 1 head because it's corresponding to a smaller value. But let me introduce this temp variable in order to make the procedure more rigorous. So we have this next. So we first save this one. And then what we do is we set list 1 next to be null, right? And then this will be a isolated node, list node. Then we can point current next to be list 1, right? Because now this is the one, just an isolated tree node object. So then what we can do is we reset the state of list 1 to be the temp because we have first saved its state. So everything will be in harmony. So now we can update the current to be current next. So this is the one case. Another case will be the list 1 value will be greater than list 2 value. Then we should use the current next pointing to the current state of list 2. So actually similar like this 5 lines of code, right? So let me do temp is list 2 next. And then we set list 2 next to be none. So this line of code just make this one, the next line to be a current will point to an isolated tree node, list node. So this is list 2. And then we uplist list 2 to be a temp, and then current to be a current next. That will be the case. So, but after this while loop, it's possible that we still not it's possible that the two list head are not simultaneous now. So in this case, one of them should have some might have some node left. So basically, if list 1, so different from the pure array, you need to extend every element. You need just to point current next to be list 1. And similarly, if list 2, so you just point current next to be list 2. And actually, we only enter one of this if blocks. So that's it. Then let's shrink this part. So we can first test it. Yeah, it passes the 3 test cases. Now let's do a submit. Yeah, actually it passes all the cases very fast. Here, I guess we will share the same comment as for problem 2570. That is, this 2-point trick in the current situation is rather fundamental, but it's very good to master it in a solid fashion. So with that said, I guess that's it for the current video. Thank you for watching.